Welcome, geometry students, to class today on this Thursday the 11th. Hope you guys are doing well. Hope you're ready to go over some math today. Let's jump right into the announcements. Go ahead and get out your pens, papers, calculators, notebooks, all the stuff that you need. Let's have a really good class period today. First of all, please make note, you will have a quiz next week. Probably Thursday. I'm not sure yet that'll be the day, but I'm leaning toward having your quiz on Thursday. Okay? Homework that is due today, well, everyone turned it in. Okay? So the homework was due today, Thursday the 11th, but everybody turned it in yesterday, which was great. Okay, so no one owes me homework. The juniors will not have to make up the homework assignment. I think Anna and Libby were absent, and they'll have to make that up when they get back. But all of you that were in class yesterday turned that homework in, so you guys owe me no homework at all that needs to be turned in today. So good job on that. Okay, incompletes. Let's take a quick look at incompletes, geometry track 2, and here we go. Of course, we don't really care about Jaden, Katie, or Jordan. They're all gone. Brandon, you owe me these 2 assignments by the end of the week, or they will turn to zeros. I need those turned in, please. No questions asked on that. So please get those turned in. If I'm wrong on you owing me those assignments, just contact me. Also, quiz number 2, Brandon, by Friday. And let's see, he's the only one that's here that has that. And then Anna and Libby, of course, owe me the assignment that you guys did yesterday. And so Anna and Libby, if you're there today, you guys owe me the assignment that was done in class yesterday on Wednesday. Okay, so please keep that in mind, and let's keep moving on with our announcements here. The schedule for today, we're going to look at an instructional video on an algebra review. Okay, there will be no homework, just a lot of notes today. Take really good notes, that'll be sufficient. And then tomorrow, if I can get this thing to work, there we go. Tomorrow, well, the video is going to be about simplifying algebra expressions, and then tomorrow we get back to geometry. Now, you say, well, Mr. Earhart, the juniors won't be here tomorrow. That's true, but what I teach tomorrow, the juniors will miss. That's true. However, they will get the same video next week when you sophomores are gone to the Creation Museum. And by the way, I wasn't sure if the museum is called the Creation Museum. If it was, then I should have capitalized these 3 words. I wasn't trying to be disrespectful. I'm just not sure if that's the exact name or not. But either way, the juniors will get the video that we're going to cover tomorrow in class. They'll get that next week when you sophomores are gone to the Creation Museum. Okay, so that's basically it there. So tomorrow's back to geometry. Let's go ahead and get started. Just continue to let this video run. There's no video you're going to watch today. This is just kind of old-fashioned. I'm going to write things down. You are going to take notes, and we'll have a really good class period, okay? So here we go. Copy this down, please. And Mr. Hamill, please make sure everybody's taking really good notes. Thank you. Everyone should be taking notes. Simplifying algebra expressions. And now you can see why I teach math and not English. I have really bad handwriting, so I'm not going to try to hide that. Hopefully you guys can read these hieroglyphics. All right, simplifying algebra expressions, and then be sure and include today's date. Okay, simplifying algebra expressions, and then include today's date. Let me flip my notes over here real quick. Give me just a second, please. And now, the first thing we need to do is establish what a term is. And you might have been a really good algebra student last year. You might not have been, but I want you to take really good notes on this. And please just humor me and write this big, long expression down, okay? Here we go. I want you to write 2a cubed b c to the 4th power g h to the 5th j m q r squared s to the 4th T U V cubed. All right, copy all that down. I have a reason for doing this, and please trust your crazy math teacher. He does have a reason for what he's doing. Please copy this in your notes. I'll give you just a second to do that. Okay, copy this down. I think one of the biggest disappointments to me as a teacher is when a student does not know how many terms they have in an expression. And one reason it's so frustrating is it's very important that a student be able to know how many terms are in an expression. For example, if you're factoring a binomial, you have to know whether or not you have 2 terms or 3 terms. A trinomial has 3 terms, and etc. And so it's very important to know how many terms an expression has. Another reason it's frustrating when students cannot tell me how many terms an expression has is because it's so easy. It's so easy to count terms, okay? Now, I want you to make a note. Maybe just kind of watch. I don't think I want you to take notes. Just write this expression down, and then just let me talk about this, okay? Everybody listen to me. Do you know how many terms this is? That huge, monster, long expression is 1 term. 1 term, Mr. Earhart? Yeah, 1 term. Because everything is doing what to each other? It's multiplying. So when you have a real long expression and it's all multiplication, that's 1 term. That's 1 term. Now I want you to write this sentence in your notes. Are you ready? Write this down, please. Write this down. Positive. Write this down, please. Positive and negative signs. This is a hugely important statement. Positive and negative signs divide an expression into terms. Okay, I'll wait just a second while you finish copying that down. Positive and negative signs divide an expression into terms. So, I mean, yes, to be picky, there's a positive sign right here at the beginning, but it's nowhere in the middle. So, when I say positive and negative signs divide an expression into terms, I don't see any positive or negative signs here. It's all multiplication. Do you see what I'm saying? That's 1 term. Now again, I don't want you to take notes on this, just watch, okay? I'm going to take this G right here and get rid of it. And I'm going to put a plus sign right here. Okay, students? Now, listen to me carefully, please. Now I have 2 terms. This is 1 term. Then I see a plus sign, and here's my other term. This would be a positive term, and this term here would be a positive term. Isn't that simple? Positive and negative signs divide an expression up into terms. All right, let's do this. Let's get rid of the T. I guess we'll get rid of the U because I just kind of feel like it. And let's put a negative sign there. All right, just watch. Don't take notes, just watch. There we go. Now I have 3 terms up here. This is 1 term. Then I see a plus sign. So here's my next term. Then I see a minus sign, and here's my next term. Isn't that easy? So this is a positive term, this is a positive term, this is a negative term. Wow, this is really simple. And that's one of the reasons I get frustrated when students don't know how to count terms. It's really not that difficult, okay? Let's put a minus sign right here. And now I have 4 terms. And here they are. I have a term right here, then a plus sign, a term right here, then I see a minus sign, and then a term right here, and then a minus sign, and then a term here. So I have a positive term, a positive term, a negative term, and a negative term. This is really not meant to be super difficult, students. It's really not. Okay, let me throw 1 more up here, and I think I'm probably boring you to death by now, but hopefully, even if I'm boring you, hopefully I'm not losing you, okay? So let's put a positive sign in right here. And then, of course, obviously we would have 5 terms. 5 terms, okay? Here's 1 term. Then I see a plus sign. Here's another term. Then I see a plus sign. Here's another term. Then I see a minus sign. Here's another term. Then I see a negative sign. Here's another term. Look at that sentence you wrote in your notes, students. Positive and negative signs divide an expression into terms. This is a positive term. This is a positive term, negative term, negative term. Okay? All right, so hopefully that helps you understand terms, okay? Now I'd like you to write a couple more sentences down here, and then we will continue on. All right, let me get this right here. Copy this in your notes if you would, please. Write this down, please. Write this in your notes, please. Okay, you can only add or subtract terms that are like. Now, I really don't like to use the phrase add or subtract. I like to use the word combine, because as you get into higher and higher level math, we really don't look at pluses and minuses as add and subtract, but we look at them as positives and negatives. But whatever words you want to use, just remember you can only add or subtract or combine terms that are like. Do you understand that? Okay. Now, you can multiply like or unlike terms. It doesn't matter. If you want to make a note of that, you can. You don't have to. You can multiply like or unlike terms. Okay. Now, I think it's very important that we talk about what a like term is. So please copy this in your notes. Copy this down, please. I want you to put like terms. Would you write that, please? And then put 2x squared, and then put negative 5x squared. These two terms are like terms. Well, Mr. Earhart, there's a 2 in the front and a negative 5 in the front. That doesn't matter. The coefficient is always the number that's in front of a term. And by the way, if there was no 2 here, then even though you can't see it, there's really a 1 right here, okay? But let me really stress to you that it does not matter what this first number is. Listen, students, this first number has no bearing on whether a term is like or unlike. What matters is the variable and the exponent. For example, these two terms are not like terms. This is an x squared term, and this is an x term. They are not like terms. However, if I put that 2 back, then I have like terms. This is what I call an x squared term, and this is what I call an x squared term. They are like terms. Okay? Now, let's take this a step further. Write this down, please. And notice it did not matter that one of them was positive and one of them was negative. That has no bearing on whether or not the terms are like or unlike. It has no bearing at all. Okay? All right, here we go. Let's see what we have here. All right, now write this in your notes, please. 3xy squared, and then put a semicolon, and then put negative 5x squared y, and then put a semicolon, and then we'll put 4y squared x. Now, I'll pause just a minute while you copy this in your notes. 3xy squared, and then negative 5x squared y, and then 4y squared x. Now, all three of these terms are not like terms. They are not. Okay? Let me show you something. Remember the coefficient, the first number right here, the 3, the negative 5, and the 4 have no bearing on whether or not we have like or unlike terms. The letters and their exponents do. So with that in mind, notice I have xy squared. Notice over here I have xy squared. Well, Mr. Earhart, they're out of order. Your x is first over here and then your y. Over here it's your y and then your x. That does not matter. All that you need to know is even though you can't see the exponent of the x, there's really a 1 right here. And so this x has an exponent of 1, and this x over here has an exponent of 1. This y has an exponent or power of 2, and this y has a power of 2. And so this term here is like this term here. They're like terms. Now this term here is not, because look, you have a 2 with the x, And even though you can't see it, there's a 1 here with the y, and that does not match the other two terms. So this term is not a like term. By the way, if I were to just stick one more letter up here like z, then this term here would no longer be like with this term over here because it has a z and this one doesn't have a z. So let me stress this to you again. When you're looking to see whether or not terms are like or unlike, you need to look at the variables and their exponents, okay? So with that in mind, let's go ahead and work on combining like terms. Please take some really good notes. I would like you to combine like terms. Copy this in your notes, please. There we go, okay? Let's simplify this expression. Well, look at your first term here. And by the way, let's stop. How many terms do I have in this expression? Well, I have a term here, then I see a plus sign, so a term here, then I see a minus sign, a term here, then I see a plus sign, a term here, then I see a plus sign, a term here. So I have 5 terms in this expression. Now, my first term is what I call an x term. Do you see any other x terms up here? Well, yes, we do. There's one right here, and there's one right here. So if you're not very good with sign numbers, then feel free to use a calculator. Type in -3 plus -6. But if you're pretty good with sign numbers, look at it like this. -3 means you owe $3. -6 means you owe $6 more. And so you owe 3, you owe 6. That means you owe 9. So a -9x. That's one way to look at sign numbers. Okay, your x terms are gone. Now your next term is a y term. Do you see any y terms up here? Well, sure you do. Here's a y term, and here's a y term. So you have a positive $5 in your wallet, and then someone else gives you a positive $8. So now you have $13, okay? And this here, this 5 here, make note of this, please. We call this a constant term. That means it stays the same. There's no variable with it, so we call it a constant term, okay? And I have a constant term here. Do you see any other constant terms up here to combine with this 5? No, we don't. So you bring down your 5. And this is your final answer. There are no other like terms for you to add or subtract or combine, however you want to say it, okay? So we're finished. Let's try another one, okay? Copy this in your notes if you would, please. Copy this down. Let's go with -4x squared minus 5z squared plus 10x minus 6z squared. Let's go back to the front here and put a 7 right here, and then we'll put a positive 10 right here. Okay, let's go ahead and let's combine like terms, or most books would just say simplify, okay? Simplify. So here we go. My first term is a constant term. Do you see any other constant terms up here? Yeah, right here. So I have a positive 7 and a positive 10. Look at that like you have $7 in your wallet and someone gives you 10 more, so now you have 17. Okay? Now let's look at our x squared. Here's an x squared. Do you see any other x squareds up here? Right here? No, that's an x to the 1 power, so no. I see no other x squared terms up here, so we're going to bring it down. -4x squared, and then we're going to cross that off. Next, I see a z squared term here, and I see a z squared term here. So I have a -5, which means I owe $5. Then I see a -6. I owe $6 more. So now I owe a total of $11, okay, or -11z squared, okay? And there's only one term left. It's an x term. I see no x terms up here, so bring down your 10x. And there we go. We are simplifying algebra expressions, okay? Simplifying algebra expressions. Really not that difficult, okay? Now let's take this a step further. And sorry about that. That's one of the homeschool students that I teach. There we go. Okay, now copy this down if you would, please. I want you to put -3 and then parentheses. x minus 2 plus 2 x squared minus 6x plus 4. Now, let's go ahead and let's simplify this expression. Now you should notice right away we have a negative 3 outside of a parentheses, and notice how the negative 3 is right next to the parentheses. That means that negative 3 is being multiplied times this parentheses. So remember the note I gave you about 15-20 minutes ago? You can multiply like or unlike terms. It doesn't matter, okay? So we're going to take this negative 3 and we're going to multiply it through this parentheses right here. In other words, we're going to take negative 3 times x, which is your first term, and then take negative 3 times negative 2, which is your second term. And when you do that, when you take the negative 3 and distribute it through the parentheses, your parentheses are gone. So negative 3 times the positive x would be negative 3x. And a negative 3 times a negative 2 would be a positive 6. Okay? Now let's continue on. Let's take this 2 and let's distribute it through the parentheses. Notice the 2 is right next to the parentheses, so I'm going to take 2 times x squared, 2 times negative 6x, and 2 times 4. Okay? If I do that correctly, it's a positive 2, so a positive 2 times a positive x squared is positive 2x squared. A positive 2 times a negative 6x would be a negative 12x, and a positive 2 times a positive 14, or a positive 4, excuse me, would be a positive 8. Okay? Now, you're never done simplifying until you have completely simplified all of the like terms. So I see some like terms here that we can put together. For example, here's an x term, and here's an x term. I have a negative 3, so I'm $3 in debt. There's another negative, so I owe $12 more, so it's a negative 15. Okay? Now, I see a constant term here and a constant term here. A positive 6 and a positive 8 would be a positive 14. And then there's one term left, 2x squared. There's no like terms to put with that term, so I'm just going to simply bring down positive 2x squared. So there, we simplified an algebra expression from up here by taking the 3 and multiplying it through the parentheses, taking a 2 and multiplying it through the parentheses, and then combining like terms. Okay, let's take a look at another problem, and then we will go from there. Okay, students, let's continue. Let's take a look at another problem. I intentionally left this problem up here because I want you to compare it to another problem. Please look carefully at this problem I'm going to show you, okay? X squared plus x plus 5 minus 3 minus x plus 6. Now, a lot of students see this x squared right here, and even though there's a plus sign right here, they think they should take this x squared and multiply it through the parentheses like we did up here with the negative 3. Well, students, can I show you something that's really important? Look at this carefully. Do you see that there's nothing between the 3 and the parentheses? There's no plus sign here. There's no minus sign here. The negative 3 is right next to the parentheses. So that's why you multiply the 3 through the parentheses. Do you see this 2 right here? Notice there's no plus sign here or minus sign. Okay, the 2 is right next to the parentheses. And so that is why you multiply the 2 through the parentheses. Now come down here. The x squared is not right next to the parentheses. And this negative 3 right here is not right next to the parentheses. There's a negative sign right next to the parentheses, and there's a positive sign right next to the parentheses, okay? but the x squared is not right next to the parentheses. And the negative 3 is not right next to the parentheses. So here's what a lot of students like to do. They like to pretend there's a 1 right here, and that really helps. If you have a positive or a negative sign right outside of a parentheses, it helps sometimes to put a 1 right here. So now you're going to bring the x squared down, and you're going to take a positive 1 and you're going to multiply it through. A positive 1 times x would be a positive x, and a positive 1 times a positive 5 would be a positive 5. There we go. So just like you took this negative 3 and you distribute it through the parentheses, you're doing the same thing down here, only you're taking a positive 1 and you're distributing it through the parentheses. Now let's come down here. Here's a negative sign right next to the parentheses. Well, if it helps you, pretend there's a 1 there, okay? First of all, we're going to bring down our negative 3, and then we're going to take a negative 1 and multiply it through. A negative 1 times x is a negative x, and a negative 1 times 6 is a negative 6, okay? Now, we got rid of these parentheses here by distributing a 1 through the parentheses. We got rid of these parentheses here by distributing a negative 1 through the parentheses. So now we're ready to add or combine like terms. My first term is an x squared term. Are there any other x squared terms up here? No, there's not. So bring down your x squared. My next term is an x term. Do you see any other x terms up here? Yes, right here. And if there's no number in front of the variable, you can put a 1 there. So I have a positive 1x and a negative 1x. Now think about that. If you have a positive $1 in your wallet, you have a dollar in your wallet, and then someone comes along and takes your dollar away, you owe a dollar, then you're left with 0x. Now, you do not have to put that 0x if you don't want to, but a lot of students like to put that. That's fine. That's up to you. Okay. Now, I have 3 constant terms. 3. So we start off with a positive $5 in your wallet, and then you owe 3. So a positive 5 and a negative 3 leaves you with a positive 2. So you have $2 left in your wallet, and now you owe $6, so you're $4 in the hole. Negative 4. Okay? And this answer here is okay. It's probably not going to be acceptable in Algebra 2, because really, if there's a 0x, that means 0 times x, and 0 times x is just 0. So there's really no need to put a 0x in there. Okay? So really the best answer you can put would be x squared minus 4, okay? But again, we're just learning how to distribute numbers or signs through a parentheses and then combining like terms after that, okay? So hopefully this is kind of making sense as we do more and more of these, okay? All right, let's continue on. Before, students, I get into these next problems, I want to remind you that our goal today is just to simply review algebra simplifying, okay? You're not supposed to be able to ace a test on this material. You're not supposed to be able to ace a quiz on this material. And you're not supposed to be able to necessarily teach the class, okay? That's my job, all right? But hopefully, as we go through this material, it'll make a little bit of sense. And then next year, when you have this material again in Algebra 2, hopefully this will help you understand a little better, okay? Let's take this a step further now, and let's look at a couple more problems, and then you'll be done with your notes for the day, all right? And you can go ahead and maybe work on some incompletes if you're missing some assignments, or take a quiz or whatever, okay? So here we go. What if I have this, write this down please, copy this in your notes, this compared to this over here. Okay, copy both of these in your notes. Now, and let's also copy one more problem in your notes, students. If you would let me do this, please copy one more thing. I want to show you one more difference here. Okay, let's copy this in your notes also. Now these problems look pretty much the same, but they're not. Okay, and so do understand that these problems are totally different. Totally different. Okay. Now watch this carefully. Here I have a binomial, or in other words, a two-term inside of parentheses. One term, two terms, okay? And then I have another binomial over here inside of a parentheses, okay? We call that, like I said, a binomial. One term here and one term here. Now notice these two parentheses are side by side, which means they're multiplying. Over here, though, notice the two parentheses are not side by side. There's a subtraction sign here. So this problem over here, even though it looks similar to this problem over here, is totally different. And then this one over here looks similar to these two problems, but it's not. Because there's no parentheses around the x plus 5, the only thing that you're multiplying the x minus 4 times is the 5. The 5 is the only thing you're going to multiply through the parentheses. Okay, so with that in mind, let's go ahead and work each one of these out, okay? And hopefully you'll see the difference. All right, so here we go. Let's start with the two that we've done already. We've done a problem like this earlier on the last page. Remember, there's a positive sign here, even though you can't see it, and there's a negative sign here. So we're going to multiply a positive 1 through the parentheses. 1 times x would be x, and 1 times 5 would be 5. Then here we have a negative right outside the parentheses, so we're going to put a 1 here and multiply a negative 1 through. Negative 1 times x is negative x, and negative 1 times negative 4 is a positive 4. And now we're going to combine like terms, okay? So I have a 1x and a negative 1x, so a positive 1 and a negative 1 would give you 0x. And of course we're not going to put 0x, and then a positive 5 and a positive 4, they're both like terms, a constant term and a constant term, and if you have $5 to the good and then you get $4 more, you're going to have a positive 9. So there's your answer. Now we've also done problems like this previously earlier in this video, and so let's go ahead and take a look at this. Notice here I have the 5 right outside the parentheses. So what I'm going to multiply through the parentheses is a positive 5. Now, if this had been a negative sign right here, then I would multiply a negative 5 through the parentheses, okay? So bring down this x right here, bring that down, and then positive 5 times x would be positive 5x, and then positive 5 times negative 4 would be negative 20. Now we're looking for like terms. I have an x term here and an x term here. Don't forget there's a 1 in front of the x. So I have a positive 1, that's $1 to the good, and then plus 5 more dollars, that's going to be a positive 6x. And then bring down your negative 20 because there's no constant term to combine with the negative 20. Okay, so there we go. Now let's come over here. This is going to be totally different than any problem that we've done so far. You have a complete parentheses times a complete parentheses, okay? So here's what you need to do. You're going to take what's in this first parentheses, x, and you're going to pick up this x and you're going to multiply it through the parentheses over here, okay? So x times x is x squared, and x times negative 4 would be negative 4x. Now if that doesn't make sense, then you might want to pause the video, back it up, and watch that again, okay? So whenever I have a group times a group, I take the first term and multiply it through the parentheses. Now I take my second term, my positive 5, and I multiply it through the parentheses also. So I have a positive 5 times x, that's a positive 5x, and then I have a positive 5 times a negative 4, that's a negative 20. And then we combine like terms. Notice my first term is an x squared term, and I see no other x squared terms up here. Then I see an x term here and an x term here. So I have a negative 4, that means I owe $4, and then I get $5, so I apply that, I have negative 4, and then I have 5, so I'm left with a positive 1 to the good, x, and then bring down your negative 20, your constant term, because there's no constant terms in this expression up here to combine with your negative 20, and you're finished. There you go. Okay, so you simplified this expression here as far as you could go, you simplified this one as far as you could go, and you simplified this one as far as you could go. Okay? Now, students, I hope this has made sense. I hope this has been a help to you, and I hope that next year when you get into simplifying, this will ring a bell a little bit, and it might help you understand this a little bit better next year as you go over this again in Algebra 2 next year, okay? Contact me if you have any questions. Have a good day today, and I will talk to you guys tomorrow on Friday.